All right, this is problem number 3 from round 4 of this week's problem set. It's a um, sort of complicated factoring problem. And so one thing, um, one thing I noticed when I first saw this is my first instinct was to do this because I see a lot of even powers. So I'm thinking a lot about squares and factoring this as though it's a quadratic. My first instinct was to do this, but this didn't work. So my first instinct was to think of this as 2x squared plus 19x squared y squared plus 5y squared. And that didn't seem to work, at least not for me. So if you figured out a way to do it that way, that's great. I'd love to hear it. Otherwise, I decided instead though to do this. So I rather than group the entire first term and consider that a square, I just considered the x to the fourth as x squared squared. So I thought of this as 4x squared squared plus 19x squared y squared plus 25, and then I thought of this y to the fourth as y squared squared. So to make this a little easier, I tend to like to substitute in variables just in like these intermediary stages to help a little bit. So I'm just going to call the x squared an a. I'm going to call the y squared a b. Okay, might just make this look a little more presentable. So this therefore would be viewed as is 4a squared plus 19ab plus 25b squared. Okay, so now what? Well, I do notice that 4a squared and 25b squared are themselves perfect squares. And so just over here for some scratch work, some more scratch work, I guess. Notice that, so this is the type of thing where I do a little guessing and checking and adjusting. So I know that 4a squared is 2a quantity squared and 25b squared is 5b quantity squared. So I'm just going to jot this down and see what this would be. I don't think this is quite it, right? That quantity squared I don't think is what we're looking at here in black, but I'm just going to jot that down and see what that would be. And then maybe make an adjustment and then just sort of have the, do the fingers crossed, have faith, technique. So if you expand this out, this binomial, you get 4a squared, you get a 10ab, you get another 10ab, and then you get a 25b squared. So all in all, you get 4a squared plus 20ab plus 25b squared. Now that's pretty close to what we have, right? It's just off by a single ab, right? We have 20ab here, whereas up here we have a 19ab. So it looks like what we're looking at here that I just underlined is this 2a plus 5b quantity squared, but I'm going to have to just subtract 1ab to make it match. So let's go with that. So I'm going to factor this as 2a plus 5b quantity squared, but then I got a minus an ab to really make it match. Okay, here's where I should probably return to what I let a and b temporarily be set equal to. So I'm going to just substitute those back in. So this is really 2x squared plus 5y squared minus x squared y squared. And here I see that I've actually got a difference of two squares, because if you think of this, well, here, let's just write this again one more time. But let's view this as quantity xy squared. Let's use some capital letters here. If you view this as capital A and this is capital B, then I'm really looking at something of the form a squared minus b squared, which you can factor to a plus b, a minus b. And so that's what we're going to do. So this is this becomes a plus b, a minus b, so that's 2x squared plus 5y squared. So that would be, that's our a, plus b, and then our a minus b is there. Okay, and so we are pretty much, just going to move this up a little bit. We're pretty much done. I guess it's just more conventional to leave the cross term in the middle, so I guess I'll just write it like that. Okay, and I am pretty confident I'm done because any type of factoring here would not be over the integers, because this is a quadratic in two variables, but 2 and 5 are not perfect squares. So I am pretty confident this is as far as I can go over the integers.